Simplify the complex fractions. Easiest way that I've found to deal with fractions like these is to replace that large fraction bar, the middle fraction bar, with a divide by and move the other one over after. So that's the first thing I'm going to do, is I'm going to rewrite this as 15 over 2x divide by 5 over 6x. Now that I have it written like this, now I can keep the first fraction as it's written, change the divide by into multiply by, and flip the fraction after the divide by sign. So this becomes 15 over 2x times 6x over 5. Now that I have it like this, you should be able to deal with it. You should be able to say, oh, I can multiply and I can reduce and all sorts of stuff. Make it a lot easier. So the 5 and the 15, 5 becomes a 1, 15 becomes a 3. The 2 and the 6, the 2 becomes a 1, the 6 becomes a 3. My x and my x just straight out cancel each other out. So what I have here, 3 times 3, 9, over 1 times 1, 1. Everything else has been canceled out. So my answer for this problem is 9. It's not so bad when you write it like that. Looking over at the other problem, I'm going to start out the same way. I'm going to make the center fraction bar into my divide by symbol. Then I'm going to have that divide by that. Something that you have to do first, though. At the edge of every fraction bar is an understood set of parentheses, top and bottom. So when I rewrite this, this is going to be open parentheses, 2 plus 1 over 7, close parentheses. Divide by, open parentheses, 3 minus 4 over 7, close parentheses. Now, since this is all numbers, I could type this all in my calculator and have my answer just easy. But because we're learning this so that we can do this down here, I have to do this by hand. And then you can use your calculator to check to make sure that you did it right. So inside each of these, I need to have a common denominator because I have add or subtract. So I need to multiply this first one by 7 over 7. So that's giving me 14 over 7 plus 1 over 7. I'm going to continue with this one. 14 plus 1 is 15. So I have 15 over 7. The other one, still have my divide by. Again, I want a common denominator of 7. So I'm going to multiply this by 7 over 7. So that's 3 times 7 is 21 over 7 minus 4 over 7. Close my parentheses. So now I take 21 minus 4, and I get 17? Yeah, 17 over 7. Now that I have it like this, I have one fraction, divide by another fraction. Now I can keep this one the same. Change that divide by into times, and flip this fraction over itself. I see the 7 and the 7 just flat out cancel each other, and I have 15 over 17 for my answer. There are no variables in this, so I don't have to worry about checking the domain. I don't have to check the denominator against the domain. So those two, fairly straightforward. Getting over to this one, I'm going to rewrite it up top here. I have x plus 3 over 12. And I'm going to rewrite that as a divide by symbol. 4x minus 5 over 15. I have one fraction divide by one fraction. So I'm allowed to do my keep, change, flip. So I have my x. Let me use a different color here so it doesn't all run together. X plus 3 over 12. Change that to times. Flip this over itself. Now I can check to see what can I reduce. 12, 15, both can be divided by 3. So that's what I'm going to do. That gives me a 4 on the bottom, and it gives me a 5 on the top here. Still have my x plus 3, because it cannot be reduced with that. There's nothing I can factor out of those. Checking my 4 against my x plus 3, can't do anything. 5 against that, can't do anything. So this is it. Put it all together, and I have 5x plus 15 over 4 times 4x minus 5. Typically, you will leave the denominator factored, and the top, you can combine it if you want to. You don't have to. I could have left this as open parentheses and closed parentheses around the x plus 3 and the 5 in front of it. That's fine. But the bottom you typically want to leave factored. Looking at my next problem. Make room for that. Again, the first thing I'm going to do is rewrite this so that I have a divide by sign instead of the giant fraction bar. And again, you have to remember that you have the parentheses at the edge of the fraction bar. So I have 1 over y plus 3 over y squared inside one set of parentheses. My giant fraction bar becomes my divide by sign. And then I have another set of parentheses with y plus 27 over y squared. And close the parentheses. I want a common denominator because I'm adding. I want a common denominator because I'm adding. So for this first one, I can multiply by y over y, and that gives me y squared and y squared. That works. The second one, I want a y squared there. This is over 1, so I have to multiply by y squared over y squared. So now I'm going to rewrite this. And I am going to erase the rest of the board so I have the extra space. So I have y plus 3 over y squared, divide by y cubed plus, let me make that a little neater, I can do better than that, plus 27 over y squared. Keep, change, flip. So I have y plus 3 over y squared. Change, flip. Okay. Reduce. I see the y squared on each top and bottom, so they just straight out cancel. So right now, what I have is y plus 3 over y to the third plus 27. I need to figure out, can I factor this denominator any? Is there anything special about this? Well, I know that 27 is 3 to the third. So this is y to the third plus 3 to the third. That's the sum of cubes. So then I pick up my book and I say, I know this is in here somewhere. I can find this. And I go through all the pages of my book and I'm like, finally, I found it. It is blah, 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 blah. Okay? Write it down. Do I expect you to memorize this? No. No, not at all. But I do want you to be able to do it on homework. So we are going to have y plus 3 multiplied by y squared plus 3y plus 3 squared. That's what my denominator is. That is following the rule. A to the third plus b to the third equals a plus b times a squared plus ab plus b squared. So that is my sum of cubes rule. Like I said, I don't expect you to memorize it. If you have to go very much further with your math, you might want to learn it, but you don't have to learn it for my class. So now I have to use this to reduce that. I'm just going to work with it up here. So I see the y plus 3 on the bottom. I see the y plus 3 on the top. They are going to cancel each other out. Okay, maybe I will write it out so you can see what I'm talking about. I have y plus 3 over y plus 3 times y squared plus 3y plus 3 squared, which is 9. Okay. And I only just now realized I made a mistake. That right there, that's supposed to be a minus sign. So that means that that is supposed to be a minus sign. Carry that forward. Fortunately, I realized my mistake before it got too big. Minus sign. And that is why I tell you, read it from a book, because there are going to be little details that you're going to forget. So looking at this now, I see my y plus 3 and my y plus 3, top and bottom, cancel each other out. I need to have something on the top, so I'm going to multiply a 1 in there. So my answer is 1 over y squared minus 3y plus 9. And that one is finished.